How's it going? All right, let's solve this question. Largest element in an array after merge operation. Okay, so says you are given a zero indexed array consisting of positive integers. You can do the following operations on the array any number of time. So you choose an integer I such that I is greater than 0 and less than the length. So I is within the range, and the number I is less than the I plus 1. So the number at a particular index is less than or equals to the next index. If that situation occurs, replace the element in the next index with the summation of the two, and then delete the element from the array. Return the value of the largest element that you can possibly obtain. Okay, so this is a very beautiful question. Okay, so for example, 2, 3, 7, 9, 3. Okay, so if we start from 2, we say that since 2 is less than 3, we can do 2 plus 3, 5, and then we move 2. So just update 3 with 5 as is done here. Since 5 is less than 7, we can add both of them. 5 plus 7 is what? 5 plus 7 is 12. We can update 7 with 12 and replace it. But 12 is not greater than 9. So since 12 is not greater than 9, we are stuck basically. So the question says return the maximum. So basically you can do this a number of ways, the plus and minus, for us to get the maximum. For example, now I said 5 plus 7, but then they did not take 5 plus 7, they took 7 plus 9. 7 plus 9 is 16. And then if you have 16, you cannot do 5 plus 16, which is 21, and get the maximum. No worries, let me just rewrite it here. So we have 2, 3, 7, 9, 3, 7, 9, 3. Right. So doing it, just doing it off the top of my head, like doing it, we can combine 2 and 3. So it becomes 5. So we're having 5, 7, 9, 3. Then we can combine 5 and 7, which becomes 12. 12, 9, 3. We can't combine 12 and 9 since 12 is greater than 9. And we can't combine 9 and 3 since 9 is greater than 3. So we end up having this array. And the maximum of this is 12. That's one way. Another way of doing it is we have 2, 3, 7, 37, 9, and 3. Okay. So we can combine 3 and 7, right? If we combine 3 and 7, we'll be having 2, 10, 9, and 3. We can combine 2 and 10, which is 12, 9, and 3, which is basically what I did before. Okay. Another way for us to do it is we could do 7, 9, and 3. We could first combine 7 and 9, which is what, 16. Then we have 2, 3. Then we can combine 2 and 3 and 16, which is what, 19. So we're having 2, 19, 3, and then we can combine 2 and 19, which is what, 21. In this case, the maximum is 21. So now we have 12, 12, 21. What's the maximum is 21. So we'll be returning 21. So basically, we're supposed to do it. The default approach would be to do it the all possible way and just return the maximum. But there's actually a greedy algorithm to this, and I'll explain that in a sec. So if we look at the second example, 5, my pencil, 5, 3, and 3. 5 is not greater than 3, so you can't combine. But you can combine 3 and 3, so it's 6. Then 6 is not greater than 3, so you can combine 5 and 3, which is what, 11. So our result is 11. Now the greedy algorithm, I said there's a greedy solution to this, right? So the greedy solution is actually to look at this question in the opposite way. In the forward way, we're going from left to right. So if we're going from left to right, basically, if the index is less than the next index, you add. Then if that index is greater than the next index, you add. But now, how about if we take it backward? If we take it backward, what we'll be doing is we'll be doing, if this index, okay, we probably don't want to start here. We can start here, right? But it's better we start here. If this index is, or oh no, we can start here. Sorry. If this index is if this index is greater than the previous one, remember this one is if the current index is less than. So now we're doing if this last index is greater than the previous index, we combine. So it's still greater than 9, no, so we don't combine, we leave it like that. Then we go to the next portion of the array. We go to the next portion of the array. Sorry about my pencil, I don't know why it's not out. So the next portion of the array is 9 and 7. 9 and 7, right? We can combine them. See, is 9 greater than the previous one? 9 is greater than 7, so we can combine them, which give us 16, 3, 2. So we can go, is 16 greater than 2? Yes, so we'll be having 19, 3, 2. And then is 19 greater than 2? Yes, we'll be having 21, 3. Before I explain it, I hope you are actually seeing the reason why we're going from left to right. It's all about optimization, I guess. We want to go from left to right so that we want to go from right to left, sorry, so that we can add up the ones at the left, so that the ones at the left can grow bigger faster, so that the one at the left can go bigger faster, hence giving opportunity for the one at the right, I'm very sorry, the one at the right can go bigger faster, so giving opportunity to the one at the left to be valid, to be less than the one at the right. I don't know if you get. If we are going from the right to the left, we're going from the left to the left so that the one at the right can get bigger. We want the values at this side to be bigger so that the values at this side can have the condition of adding up. Meaning that we want, if we do 9 and 7, 9 and 7 becomes 16. It makes it bigger so that 3 can add up. Let's use this example. This example is a good example because if we go from left to right, 5 cannot match up with 3 at first, but going from right to left, we match this up first so that this part can be bigger. It then becomes 6, making the left part smaller so that it can be valid for addition. That's basically how it works, and that is what we're going to be doing. That's exactly what I'm going to do. We're going to be adding from right to left and doing exactly this, but because of time complexity with changing index and removing, because of, if you notice, we're actually chopping off the array from size 3 to size 2, from size 1 2 3 4 5 5 to 4, and chops. We'll do it in a more optimal way so that we don't have to deal with the complexity of popping an array. What we'll be doing is we'll be constructing our array. So we can start with results, and our array is going to have the first index from the ending. So let's use this example as an example. We'll start our result. We'll be constructing a result, and the result will have an array having the last element at first. So once we have the last element, we would now be going through backward, right? But this time we'll be starting at 9 because we already have 3 in the result. So we'll be doing the reverse. Is 9 greater than the next one? The next one will always be the top element in the array. So is 9 greater than 3? 9 is not greater than 3. So what we just do is we just append results. We'll append 9 to the array. So we go to this next index. Is 7 greater than 9? How do you know the value? The next value. The next value is always going to be the last value in the result. So is 7 greater than 9? 7 is 7 greater than 9. 7 is less than 9, right? So it's valid. Basically, you actually want to do the last value greater than the previous value, or the previous value greater than the next value. So is 7 greater than 9? Yes. Since 7 is greater than 9, we'll be updating the array instead. So our array will just be having 3 and 9 plus 7. 9 plus 7 is what? 16. So we go to the next one. Is 3 less than this? Since 3 is less than it is valid, right? So we update our array again. 3 plus 16 plus 3 is what? 19. So we go to the next one. Is 2 less than? 2 is less than. It's valid again. So we update our array. Our array will now be 3 and 19 plus 2 is what? 21. Then we're at the end of the array. So at the end of the day, we get this constructed array, which is actually what we've constructed here too, but just in the reverse, because of we're moving in the reverse this time to make it greedy. And we just return the maximum of this last array, which returns 21, basically. And that is how you solve it. Let's go to the coding. I'll explain more in the coding. So if you didn't get it here, you probably get it in the coding. All right. So what we want to do is we want to start by, let's just say our result. And our result, we want our result to have the last index of the norms. So if you use -1 in Python, it's going to give you the last index. So in this situation, it will give you 3. In this situation, it will give you the last index here. The value of last index here, 3. Now we want to loop. So I want to do for I in range of length of norms -1, -1. Yeah. Am I correct? Yeah. So this DAX basically starts from this array, this index, and just goes down. But remember, we don't want to start from this index. We want to start from this index. We are starting from this index because we've already updated. We've started our array by initializing like this, right? So what we do in this situation is, instead of -1, we do -2, so that it starts from this index, the index right before it. Okay, so now we'll do our if statement. So we want to know if the current value, which is norms I, if the current value norms I, that's this value, is less than the last value in the result. If it is less, it means that it is a valid. So for example, 7 and 9. This index is, this 7 is less than 9. It means that it's valid. If it's valid, what do we want to do? We want to update that 9. So we want to basically update results dot the last index. We want to update it by adding the value in that last index plus this new value norms I, right? Yeah. If that does not happen, so we want to actually do it if it's less than or equals to, right? So for example, this 3, we want it to work. So if that doesn't pass, what do we want to do? We just want to append. So we want to do result dot append. We want to do result dot append and just append this new value. So for example now, in this situation, since 9 is not less than 3, we just want to append by updating the array. So it's going to be 3,9. Yes. And once we append, we now want to return the maximum of this array that has been built up. Want to result the maximum of this array that has been built up. If we test that now, we'll be having, yeah, it works. Yeah. So basically what happens is, at first it starts with it builds it up backward. It starts with an array of 3, then checks if this 9 is less than 3. If it's not less than 3, you just add it to the array. Then it checks if this 7 is less than the array that we just added. It is less than, so we add it up, which now becomes 16. Then we check this 3 if it's less than the array the last array in the index, which is actually 16. You know, the last array in the index is the array that is just beside this new array. It's like the last array, the last object value added in the array is the adjacent value to the next array you're calling. So 16 is not the adjacent value to 3. When you add it up, 2 is not the added value to 19. Yeah. Then 2 plus 19 is 21. So now your array is just going to be 3 and 21, basically. You are using Python, so you can actually shorten this like this. So it also like that. and it was. So now I'm just going to submit this. Fingers crossed, no hidden test case. All right, cool, and it works. So that's basically how you solve. What's the name of the question again? Largest element in an array after merge operation. Basically, we're using a greedy algorithm. We're trying to be greedy with the way. We're trying to play it smart. We're trying to be greedy with the way we pick. We're trying to go from right to left so that the right can build up faster, so that the left can be more valid. If the right builds up faster and the left is smaller, it makes it more valid so that it can all add up. And that's how it works. Thank you.